Alright, now let's try to fix this, okay? So exercise 2, complete this sample answer for the writing task with words or figures. So first of all, you have to look at the diagram here, and then you have to answer all the questions there, right? Have you finished? Yeah? Okay, now let's fix this. Quỳnh Hương, you can read the first one. Starting from the diagram. Yes, 56%. Okay, the answer for the first one is 56%. Here, the diagram compares two different ways of producing energy. So you can see from the diagram, we can see two different ways of producing energy, right? And then what? The conventional system involves a thermal power plant. The conventional system, that is the one on the left side, right? Conventional power generation system. How can they describe this? The conventional system involves a thermal power plant. At the first stage, at the plant, 56% of the energy put into the system is not used and becomes waste heat. Do you see that number? They mention unused exhaust heat, 56%. Okay, so that's why here they mention at the first stage, at the plant, 56% of the energy put into the system is not used and becomes waste heat. Now tell me, why do we need to, which tense is this? Yeah, present simple tense. Why do we need to use the present simple tense? Yeah, it just describes a process here, right? It didn't mention anything about the past or the future. It just describes something just about the fact, what is happening, okay, the process. So we just use the simple present tense here, yeah? And 56%, you can see it's right here. All right, next, Boeing. Yeah, you can read that one as well. Another one. No, we need a number here. What is the answer for this? Guys? 4%, yes. So the answer for number 2 is transmission cables. And number 3, that is 4%, yeah? At the next stage, power goes from the plant through transmission cables, and at this stage, another 4% of the energy is lost. Okay, now let's check the diagram together and see whether it is described correctly or not. Okay, so at the next stage, so the next stage right here, yeah, transmission. You see the word transmission cables, right? Power goes from the plant. Yes, you can see power go from the plant through transmission cables. You can see from the pictures, right? And at this stage, another 4% of the energy is lost. Where is that 4%? Where can you find information for that one? Why do you know that at that stage, another 4% of energy is lost? Where is that? Yes. Here you see they mention transmission cables, right? And then they say total loss in station power, transmission loss, etc. So that is 4%. Yeah? So at the first stage, they lose 56%. And now at this stage, another 4% is lost. Okay? Alright, next one. This means that
only 40% of the power is used at the end of the process, and this is used as electrical energy.
yes, okay. So the answer for number 4 is 40%, and number 5 is electrical energy. Okay. So this means that only 40% of the power is used at the end of the process, and this is used as electrical energy. Okay. Yes, so you can see like from the first stage and the second stage, this system loses 60% of the energy. Okay. So only 40% left. So that's why they mention here, this means that only 40% of the power is used at the end of the process, and this is used as electrical energy. Why do you know the answer for number 5 is electrical energy? Where? Yeah, on the system on the left, right? You can see they mention electrical energy 40%. So that means only 40%, okay? Only percent of power is used as electrical energy. Okay? Only 40%. Okay? So we have just finished the first system. Now let's talk or let's write. Okay, now let's discuss about the second system. Okay? Next.
In the early system, natural gas is used as the source of power. Power comes from the LNG terminal through a pipeline to a gas engine.
Okay. In the other system, that means the system on the right side here, natural gas is used as the source of power. Power comes from the LNG terminal through a pipeline to a gas engine. Now, the first sentence, in the other system, natural gas is used as the source of power. Why do we know this?
Because it talks about the system on the right.
Yes, you can see they mentioned the name of the system. That is natural gas-fired cogeneration system. Okay. So that means that in this system, natural gas. You see they mentioned the name natural gas. Okay. So that's why natural gas is used as the source of power. Okay. That's also the name of the system here, natural gas-fired cogeneration system. Okay. And next one, they say power comes from the LNG terminal. Where can we see that? Where can we see that information? At the first stage of the system, right? You can see they mention LNG terminal, right? So that means power comes from the LNG terminal through what? Through a pipeline. You see they mention the name pipeline. Okay, they mention the word pipeline there. So what you see in the picture or in the diagram, that's what they call a pipeline. So you just mention pipeline there. Okay, power comes from the LNG terminal through a pipeline to what? To a gas engine. You can see the word gas engine right there as well. Okay, so it just describes the system. All right. Next.
At this time, between 10% and 30% of the energy that has been produced is lost.
Yes. Okay, just stop right there. Yeah. At this stage, between 10% and 30% of the energy that has been produced is lost. So at this stage, at this gas engine stage here, okay, what? Between 10% and 30% of the energy that has been produced is lost. Where? Where does that mention? Yes. here you see like the power is transferred from the LNG terminal to the gas engine through a pipeline, and here you see they mention here unusable exhaust heat 10 to 30%. Okay, so that means that 10 or 30% of the energy is lost. Okay, that's why they say at this stage between 10% and 30% of the energy that has been produced is lost. Okay, next. Okay, Như, you can go next as well.
Of the power that is not lost, 30 to 60% of it is then used for thermal energy, and 20 to 45% is used as electrical energy.
Yes. Okay. So this one is a little bit different from the one before, because here they say that of the power that is not lost, 30 to 60% of it is then used for thermal energy, and 20 to 45% is used as electrical energy. Okay, so the number 30 to 60% is of the energy is used for thermal energy. We can see it right there. Yeah, thermal energy 30 to 60%. And electrical energy 20 to 45%. Now tell me, why do they have to mention that? Do you think that the number 30 to 60% or 20 to 45% makes sense or not? Because we already lose 10 to 30%, right? Why do we still have the number 30% to 60% here, or 20% to 45%? Does that make sense? Yeah, why it makes sense? Because in total you should have only 100%, right? In total you should have only 100%, but why here you only lost 10 to 30%? So why we still see the number 30% to 60% and then 20 to 45% here? Why? So that's why they have to mention here, they say that of the power that is not lost. Okay? So how many percent is lost at this stage? Gas engine?
10 to 30%.
Yes, 10 to 30%. Okay? For example, like if the percentage which is lost, that is 30%, so how many percent do you still have left?
70 to
Yeah, you still have like 70 to 90%, right? So if we lose like 30%, you still have 70% left. And here they say that of the power that is not lost, that means in that 70% left, and we call that 1% of 70%. Okay, so they say that in that 70% left, how many percent has been used for thermal energy? That is 30 to 60%, and 20 to 45% is used for electrical energy. Okay, so that makes sense, right? Okay, but you have to mention this one, of the power that is not lost. If you don't mention that, everything goes wrong. You understand? So it's different from the first system, right? Because the first system, they say that only 40% of the energy is used for electrical energy. Okay, because because with this system it loses 60% on the way, so they have only 40% left, and all of that 40% is used for electrical energy. Okay, but the second system, that's different. Okay. All right, next. Quỳnh Hương, next one, the comparison.
The comparison shows that the conventional system
Yes, the comparison shows that the conventional system is less energy efficient than the other system called a natural gas-fired cogeneration system. Okay? So here, remember they say that summarize the information by reporting the main features and make comparisons where relevant. Okay? Remember that? So you always have to make comparisons where relevant. Yeah? So that's why here they say that the comparison shows that the conventional system, that is the system on the left side, is what? Is less energy efficient than the other system, than the one on the right side, called a natural gas-fired cogeneration system. Why do we know that? Oh, because they explain next to that. Okay? TOEIC, can you please read the next one? Yes, that's right. It's only explains here, right? The overall energy efficiency of the conventional system is only 40%, meaning that only 40% of the power it produces can be used. It's correct, right? Because it loses 60% on the way, and only 40% can be used as can be used for electrical energy. Yeah. How about the other system? In contrast, Ngọc Anh, please read that.
In contrast, the system based on natural gas is much more efficient, as between 70 to 90% of the energy produced is used.
Yes, in contrast, the system based on natural gas is much more efficient, as between 70 and 90% of the energy produced is used, right? So that means that with the second system, they only lose around 10 to 70%, 10 to 30%. So that means they still have around 70 to 90%, okay? So that means it is more efficient than the other system. Okay? Alright guys, so that's it for our lesson today. We'll continue next week.